All right, so this is part two for module one. This particular video deals with graphing and with equations. So let's take a look. Okay, you received a copy of equations and graphs. And what this is this is just a summation of everything that you had in that. So let's take a look. Whoops. So the first thing, I want to talk very briefly about graphs, and these graphs are on a PDF file that you'll be receiving. I'm not going to do much with it. You should know how to graph pretty well. It's like you should really know how to solve the linear equations. We're going to do pretty well as well. Okay, but first off, I want you to note that you should be able to graph with TI. Okay, so press this link and learn how to graph with your TI if you don't know already how to do that. Okay, it's very important that you know how to do that. If we do have to graph by hand, we're going to use input-output tables for the most part. We're going to choose 3 separate x values. We're going to substitute the x in and solve for y. Next, we go on graph paper, we plot x and y axis, and we scale with a meaningful scale. And we plot the 3 ordered pairs that we found in this input-output table. And then we connect. And then that's it. So for example, the first one, y equals minus 2x plus 3. I'm going to input -1, 0, and 2. And my why? Because it really doesn't matter what I input as long as I input something. And so when I put input -1, I get -1 times -2 plus 3. Combines to be 5. When I input 0, I get 3. And when I input 2, I end up with -1. So that gives me these 3 ordered pairs. I plot them and connect with a line. Then you'll see on the ordered pair, or I'm sorry, on the ordered pair, on the PDF. We try y equals 2/3 x minus 3. One thing to note is if there's a fraction in front of the x, one thing you can do is you can consider using the denominator, negative the denominator, and 0. Why the denominator? Because when I plug the denominator in of 3, it cancels this 3 with this 3. It cancels out the denominator. And that gives us 2 times 1 rather than 2/3 times 3. Okay? And 2 times 1 is 2, minus 3 gives us -1. Negative the denominator down here does basically the same thing, except when we cancel, we're left with a -1. Okay? And that'll give us -5. The in between, 0, that gives us -3. And again, this one will be on the PDF as well. All right, now this should be, for the most part, review, solving equations. However, we'll review it very quickly. Okay, simplify both sides just by distributing combined like terms. Collect variables on one side, use an addition property. Collect non-variable terms on the other side, use an addition. Then make sure there's a 1 in front of the denominator, either by using the multiplication or division property. And then check your answer. Okay, so let's take a look at the solutions to this. I think I have the solutions up here. And let's take a look at our first one on our sheet. This should be pretty straightforward. This one, we just combine the -15 and the 5. And then we get 5x minus 10 equals 7. Add 10 to both sides. There's that addition property. Divide by 5. That gives us 17/5. This one, b, we distribute the 2. Gives us 2m minus 8 equals -4. We add 8 to both sides, giving us 2m equals 4. Divide both sides by 2, and we get m equals 2. C, a little bit more complicated. We distribute the 4, giving us 4x minus 4 minus the 2 equals, distributing the 5, 10x plus 15 plus the 6. We'll combine the -4 and the -2 here, giving us 4x minus 6. We'll combine the 15 and the 6 here, giving us 10x plus 21. Then we'll start using the addition property. We subtract 10x from both sides to move the x over to this side. We'll add 6 to both sides to move the non-x terms to that side. 4x minus 10x gives us minus 6x. 21 plus 6 gives us 27. We divide out both sides by -6. And we get x equals minus 27 over 6, which reduces to be minus 9 over 2. Equation D, we distribute the 8, giving us 8 cubed plus 8 minus 5. Combine the 8 and the minus 5, and we get 3. Yes, my dogs and cats sometimes like to tell you they're there. And then 3 times 2 cubed, we'll distribute the 3 here, gives us 6 cubed. And 3 times 3 gives us 9. We add the 9 and 6 together, and we get 15. Now again, using the addition property, we'll move the 6q over by subtracting 6q. That gives us 2q. And we move the positive 3 over by subtracting 3. That gives us 12. When we add up the 2q and the 8q rather, and the minus 6q, we get 2q. Divide both sides by 2, and we get q equals 6. And you should be able to check those. How can we check them? By taking the answer we have and plugging in for the variable in the original equation. Left side has to equal right side. When there are fractions present, we clear out the fractions by multiplying everything by the common denominator and canceling it. So we have a 1/4 x, a 1/2 x, and that equals a 5/8. So the common denominator between 4, 2, and 8 is 8. So we multiply everything by 8. When I multiply the 8 times 1/4 x together, the 8 and the 4 will cancel, giving us 2. So that ends up giving us a 2x. That's what we have here. When I multiply the 8 with the 1/2, 8 times 1/2, that's 8 over 2. That gives us 4. That's what we get here. And then 8 times 5 over 8. 8's cancel cleanly, giving us 5. And then we solve like we normally would. So we have a 2x, and subtract the 4 from both sides, equals 1. Divide by 2, and we get x equals a 1/2. F is pretty much handled the same way. We have a 5, a 2, a 3, and a 4. The 5 has a denominator of 1. So the common denominator is 12. So we multiply everything by 12, including the 5. Just nothing gets canceled there. So 12 times 5 is 60. If I multiply y over 2 by 12, the 12 cancels with the 2, giving us 6y. When I multiply 12 with the 2y over 3, the 12 partially cancels with 3, giving us 4 times 2y, or 8y. And when I multiply the 12 with the minus 3y over 4, the 12 partially cancels with 4, giving us 3 times 3y, or 9y, and it's negative. So when I combine all these y's together, I have 6y plus 8y, which is 14y, minus 9y, which gives us 5y. 5y equals 12, means y equals, 60 equals 5y. So that means that divide both sides by 5, we get 12 equals y. Sometimes we have a fraction in front of a set of parentheses, and that's all we have in the equation. No other fractions. We still multiply by the common denominator to clear it out. So we just multiply this fraction in front before we distribute by 3. That clears out the 3. Now I do have to multiply the other side by 3 as well, so don't forget that. Okay, we'll multiply one side by 3. You have to multiply the other side by 3. And so that gives us 2 times 3m minus 6. Distributing the 2 gives us 6m minus 12. Distributing the 3 over here gives us 15 minus 3m. And then you can follow along and find that we get m equals 3. Now there are 2 types of notation that we have when we talk about inequalities. One is called a number line notation, and the other one is called an interval solution. The number line notation, or solution, let's suppose we have x is less than or greater than 3. Okay? So when we have a less than or greater than, we use an open circle. We have a greater than or equal to, or a less than or equal to, we use a closed circle. Since this is greater than, we use an open circle at 3. 3 is what we call a critical point. Now, here's the trick. If x is on the left side, whatever direction this inequality arrows to, that's the direction that we arrow on the number line. So since this arrows to the right, and x is on the left, we arrow in the right. Just like if we have this, x is greater than or less than or equal to minus 5. So we close at -5. That's our critical value. Okay. And then our arrow points to the left. X is on the left, so we arrow left. Now, what happens if X was over here on the right? Well, then we would do the opposite direction as inequality points to. Okay, we also have what's called compound inequalities, when we have two inequalities in one problem. In this case, it says x is less than, 3 is less than x is less than 7. So that means 3 has to be greater than x, or can't talk. X has to be greater than 3, but x also has to be less than 7. So it has to be between 3 and 7. Since both of these are less thans, we have open circles. Everything is shaded in between. We could also have partially open and partially closed. Partially open and partially closed means we have a less than or equal to for the 3 this time, but strictly less than for the 7. Okay? And so we do the same idea. We close the 3, keep the 7 open, and shade everything in between. Interval notation uses parentheses and brackets. Parentheses means that it's open at that point. It can't be included. That's like a less than or greater than. Brackets means it's closed at that point. That means that you can use that point, and that means it's like a greater than or equal to or a less than or equal to. We can get half open and half closed, or we can get fully closed like we have here, or fully open like we have up here. So if I say x is greater than 3, 3 is not included, so I'll use a parenthesis, and it goes on forever. Forever is infinity. So we use this lazy 8 symbol for infinity. We can never get there. So for infinity, we always use parentheses. When we say x is less than or equal to -5, this is negative infinity. So we never can get there. So open parenthesis. But since it's less than or equal to -5, we can include 5. So we are -5, so we use brackets. For the 3 is less than x is less than 7, we have open at both 3 and 7. For the 3 is less than or equal to x is less than 7, we have closed at 3 and 7. So these are used when we have inequalities. Remember, inequalities are handled exactly the same way equations are, except if we multiply or divide by a negative number, we must change the direction of the sign. And so we have 11p minus 36 is less than 7p minus 28. We do the same thing we do with an equation. Subtract 7p and add 36 to both sides. That gives us 4p is less than 8. When we divide, this is a step we have to watch out on. We're going to divide by 4. 4 is a positive number, so nothing changes with the inequality symbol. When we divide both sides by 4, we get p is less than 2. So less than 2 means it goes from negative infinity up to 2, including neither. So we put in parentheses. This one, minus 4x minus 6 is less than or equal to 18. Add 6, since x is already on one side. Now in this case, we're going to divide by minus 4. Since we're dividing by minus 4, we have to change the direction of the inequality. When we change the direction of the inequality, it goes from less than or equal to greater than or equal to minus 6. So that means x is greater than or equal to minus 6. In interval notation, we close the minus 6, open at infinity. And then for C, we have 9y plus 2 times the quantity y plus 6 is greater than 5y minus 24. So we'll distribute the 2, giving us 2y plus 12. Combine like terms here, get 11y plus 12 is greater than 5y minus 24. Move the 5y over with the addition rule. Move the 12 over with the subtraction rule. And that gives us 6y is greater than minus 36. Divide by 6. 6 is a positive number, so nothing changes. We get y is greater than minus 6. So that means that open at minus 6, open at infinity. Compound inequalities are handled like regular inequalities. We do everything at once when it's less than in both directions. So in other words, if I just had 5 is less than 4x plus 1, I'd subtract 1 from both sides. If I had 4x plus 1 is less than 9, I'd subtract 1 from both sides. Since I'm subtracting 1 for both of these, I do it all the way across at once. Same thing with the division. So 5 minus 1 is 4. 9 minus 1 is 8. So we get 4 is less than 4x is less than 8. We're going to divide everything by 4. And that gives us 1 is less than x is less than 2. So in interval notation, we're going to include neither. So we put parentheses around 1 and 2. Number line, open circle at 1, open circle at 2, shade everything in between. For this one, same idea. We'll subtract 2 from everything, then divide by 5, and that gives us 2 is less than or equal to x is less than 6 over 5. So we're going to be closed at minus 2, open at 6 over 5 because of the type of inequalities we have, a less than or equal to at minus 2, and a less than at 6 over 5. And so on the number line, closed at minus 2, open circle at 6 over 5. And the same thing, we're going to do the same thing for C. Except for C, when we do this, when we add the 2 and divide by 4, we get minus 1 and 0. They're both closed because we have less than or equals for both. Hopefully this helped.